Let's look at how we multiply decimals by decimals. The process for multiplying decimals by decimals is really nothing new to you at this point. We're going to use the same process that we did when we were multiplying decimals and whole numbers. We're going to start by estimating what our answer should be, so we can look at our work and realize the reasonableness of the calculations we've performed. We're going to treat the multiplication as if we were just multiplying whole numbers. We're then going to count the number of decimal places in our original problem. That means we're going to look at how many digits are to the right of the decimal in the numbers that we are multiplying. We're then going to use that number to place the decimal in our answer so that we have the same number of decimal places in the product. Please make sure you've written all of these steps down, or you've made a reminder that these steps are really the same as those that we were working with in the previous lesson. Let's start by looking at multiplying 3 6/10 times 5/100. And if you think about 3 6/10 as money, that's like $3.60. So as we estimate, we can recognize that that's closer to $4 than $3. So we can round up, and 5 cents is really close to 0. So we're looking at an estimate of 4 times 0, or 0. So at this point, we can set up our multiplication problem. Now you'll notice that we haven't lined up the decimals in this problem. When you're multiplying, it is not necessary. We're only going to line up those place values when we're adding or subtracting, because we don't stay within the place values when we're doing multiplication like we do with the other two processes. So we're just going to stack up the digits starting at the right, and then we'll place the decimal in the end. We'll treat this as if we're multiplying 36 times 5. So we'll start with 5 times 6, which is 30. Carry the 3. We've got 5 times 3, which is 15, plus 3 would be 18. And then we can look at the fact that we have 1 decimal place in our first number. We have 2 digits to the right of the decimal in the second number. So we will need 3 digits to the right of the decimal in our answer. So we'll start at the right and we'll count over 1, 2, 3. We'll place our decimal. And typically, when we have a number like this where there's not a value in the ones place, we will put a 0 in as a placeholder. That helps our readers see that decimal in our number. Make sure you've made a note about the fact that these decimals don't need to be lined up in our multiplication processes. Alright, our next example is looking at 1 4/10 times 67 thousandths. It's really important that we start reading those decimals with place values so we can better understand their meaning. So we're looking at two numbers that are both close to 0. 1 4/10 is really close to 1, and then that 67 thousandths is close to 0. So again, we're looking at a product that's going to be somewhere in the neighborhood of 0. We don't need to line up the decimal values. We'll just stack the digits starting at the right. And then we can proceed with the multiplication. We'll pretend that this is 67 times 14. 4 times 7 is 28. Carry that 2. 6 times 4 is 24, plus 2 is 26. Okay, so we're finished with multiplying by the 4, so we're going to move over a place value. So that's like multiplying by 10. We're going from the tenths to the ones. So we're going to put a 0 right here, kind of as a placeholder. That's really reminding you that we're multiplying by something that's 10 times bigger than our last number. So now we can proceed with the 1 times 7 and the 1 times 6. And then we can add these digits together. Again, the process is just like whole number multiplication. 13 plus 1. Okay. And then we'll count decimal places. We have 3 digits to the right of the decimal in our first number, 1 in the second. That means we need 4 digits to the right of the decimal in our answer. We'll start at the right. We'll move 1, 2, 3. And if we need more, we're going to annex a 0. That means put another 0 to the left of the digits that we have so that we can properly place that decimal. And again, we don't have anything other than 0 in the ones place, so let's make sure we get a 0 in there for a placeholder. All right, it's your turn. You're going to pause the video and try these two problems on your own. Remember to do your estimating first, and you can use the commutative property to put the number with the greater number of digits on top to ease the multiplication process on your paper. All right, try these two and then check when you're finished. All right, in the first exam, first you try it. If we estimate, we can round that 14 7/10 up to 15 and the 11 and 361 thousandths down to 11. So we should get a product of somewhere around 165. Check your calculations against what you see here on the screen. And then notice that we have 3 digits to the right of the decimal in the first number, 1 to the right of the decimal in the second, which means we need 4 digits to the right of the decimal in our product. So start at the right and count over. And if you place that properly, we get 167 and 67 ten-thousandths, which is really close to 165. If we put that decimal in any other place, we'd be moving further away from our estimated value. All right, in your final example for this lesson, we had numbers that were close to 27 and 1. So our estimate should give us something around 27. Check your multiplication against what you see. And then notice that we had a total of 5 digits to the right of the decimal in the problem, which means we need 5 digits to the right of the decimal in the product. And when we place that, we get 29, a little over 29, and that's pretty close to 27. So our work here is good. Please remember to write down any questions and bring back to class so that we can have our discussions.